All right, hello everyone. Welcome to the COSE working group session for IETF 108. If you've been here, you've probably have seen this, but it's important to call out the note well. Reminder that IETF policies are in effect here, and this includes code of conduct and patents. Move on. So we're going to take care of some administrative things here first. Thank you, Francesca, for volunteering for note-taking. Is anyone willing to Jabberscribe? This is if somebody can't speak for whatever reason, to be able to bring that to the mic. Was that Michael Richardson volunteering?
I think so.
Yeah. Thank you, Michael, for volunteering. All right. And anybody that's willing to help Francesca, that would be great. I believe the link is, if I will provide the link further up in our Jabber chat. Couple of Meet Equi tips that chairs have found helpful. If you do want to queue at the mic, make sure you always request audio. You can request video if you like, but make sure you at least request audio. If you are speaking, please first state your name. It's not, there's no other indication immediately available for everybody. And if you are taking or tracking notes, it would be helpful to open them in a new tab or window. That way you could still see what's going on and be able to get back to hums. So with that out, today's agenda, we're going to go over the document statuses. This also includes a quick comment with Jim to go over an issue with the 8152 struct. Then we'll hear about cert compression, more algorithms, and wrap up with chartering. Is there any bartering over this agenda or any changes that are desired? All right, well then moving on. So moving on to pointing out some documents that have already progressed. So COSE HashSig has been published since the last time we all talked. And the web authn algorithms is currently in the RC editor review. So this, if I'm remembering the state correctly, the next stage here is auth 48. So we're moving right along. A document that's with our area director is COSE X509. We've requested publication. We're awaiting AD review before we move on to IESG and IETF last call. See, things that are still with the IESG are in IETF last call. So the COSE hash algs that Murray graciously took over, looks like it's approving. Once we've gotten a revised internet draft, it should have approval. Hash algs, there's a revised published waiting AT review approval and whatever the outcome is of 8152 bis struct, which there's an outstanding discuss that we will be talking about here very shortly. That is then all the documents that we've had chartered for this group so far. Let's see. So, if there's any comments, questions? Okay, Jim, I think we are ready to talk about the structure discuss.
Okay, so it took about 4 weeks for me to figure out exactly what Jean-Marc was talking about in terms of what his discuss was. But I actually finally figured it out, and I agree that it's something that needs to be dealt with. So, next slide. So, this is basically going to be kind of a recap of the message I sent out, but with some colors and arrows to make things easier to see. So, the way things are set up right now, if you get a real counter signature, you take the protected attributes from the thing you're countersigning, and you take the cryptographically changed content, whatever that means, and you combine those two things together as part of your counter signature creation process. So this is true for both of the COSE encrypt things, the COSE recipient, and the COSE signer, where that is actually really cryptographic content that is in that field. Next slide. There are, however, a couple of structures where that content is either, if the content that we're looking at is actually plain text content, or so it hasn't been cryptographically modified. And for COSE signature, there is no cryptographic content. So the best thing you can do with that is to basically create a parallel signature. But for the MAX and COSE sign 0, there is actually cryptographic content that is part of the structure. It's just not the third element in the structure. So you actually, so right now what we do is we always generate what is essentially a parallel structure for that. And we say that is true for signature, and we say that is true for both of the MAX structures. But we don't say that that is true for the COSE sign 0 structure. And that is what the discuss itself was actually about, was the fact that COSE sign 0 did not say it was generating a parallel structure. It implied it was creating a counter signature. Next slide. So we've got a couple of options, one of which is to change the definition of the counter signature algorithm so that we actually always include some cryptographic content that is into that counter signature processing algorithm if there is any present. So COSE signature would still basically produce a parallel signature, right, because it doesn't have any cryptographic content. But for both of the MAX and for COSE sign 0, we could, if we change the algorithm to include that cryptographic content, we can produce a real counter signature type structure. How beneficial that is for MAX, I don't know, but it would certainly be more what people would expect in terms of the sign 0. So if we change the counter signature algorithm, we basically have two options. Option number 1 is to include every beaster object which is in the structure. And option 2 is to include the first and the last, under the assumption that the last one is always going to be cryptographic content, and the middle one would be probably not cryptographic content. So including all of them is an extremely aggressive thing. You're not only, it says you're you'd obviously be signing the plain text message as well as the cryptographic content, which is unusual, but it is functional. Including just the first and the last has a potential of a problem in the future. If we define additional COSE structures which don't put the cryptographic content last, or have multiple cryptographic contents that you may want to sign. So for example, there is some discussion, and I still have not figured out in the CFRG working group exactly what there's a document about doing some type of content plus message distribution in the same concept somehow, and I never figured out exactly what that document was, but I could see that document potentially ending up as a COSE structure where you have both the encrypted content and the key distribution objects as separate fields in a COSE structure. And at that point, you would probably want to include both of those things in your countersignature computation. Thus the reason why I put in the include everything. The other problem with it is you may end up with things which are not interesting, but are still wrapped in beasters. And since they are not interesting, they potentially could be modified, and that would break the countersignature. Does anybody have any questions about what I've described at this point?
Well, Ben jumped straight in, and we'll give him an option, and then Corin.
Oh, okay.
Okay, sorry to jump the queue. This is Ben Kaduk. Jim, could you, perhaps after Yaron asks his question, could you just reiterate what the drawbacks would be for including all of the beasters?
Yes.
Okay, Yaron, please go ahead.
Okay, thanks. Yaron Selander. So this, there's just one thing I noted in your mail there. You don't want this to be individual per struct. You want to have the same structure for all, because you want to be able to pick out the fields and verify the signature before. Or what is the reason for that?
Having a single algorithm, one, makes things simpler.
Yeah.
And just because you have a single thing you can implement. And two, means that you don't have to actually deconstruct and figure out what the base object is before you start either producing or verifying the countersignature. So that the processing is exactly the same whether it is an encrypt structure or a recipient structure. And potentially the only way you can tell the difference between those is to pull apart the protected attributes and look for an algorithm identifier.
Yeah, I can see the advantage of that, but that is an option also to allow differences between different.
Yes, that would also be an option.
Okay, thanks.
Ben, the drawback is not in any of the structures we have defined today. The thing I'm worried about is potential structures defined in the future, where you might have a beaster which wraps something which is which it was intended to be unprotected, as opposed to protected. There are a couple of different ways that could be addressed. The easiest one would be to tag it. so that it is so that it doesn't. It's not a beaster. It's a tagged beaster, and therefore you would know not to include it. But if someone defined a new unprotected attributes type thing and wrapped it in a beaster, that would suddenly give you the potential of breaking counter signatures if that what was intended to be an unprotected structure became part of the counter signature content, signed content. Does that make things clearer?
Helps, yes. So it seems like regardless of if we choose the first or last, or sorry, if we choose the first and last option versus the all option, we still have to worry about future proofing against any new messages that are defined in the future.
Correct.
And so in some sense that becomes a question of fail safe versus fail open, although I guess the example that you just presented is not exactly a fail safe when you include the all beaster option. But it seems like anybody who is defining a new message type in the future might be expected to read some spec or look at the registry or something, or have a designated expert review. That would be an opportunity to point out that if you do want your attributes to be unprotected, you should use the tag booster. So that would sort of be my inclination to do the thing that is feeling safe most of the time and give guidance to people to avoid the case where it's the wrong thing and how to do so.
Yeah, after doing this presentation now, I think that is probably a much easier method in terms of describing things. Next slide, please. Okay, so this was basically the slide I wrote up to say, now I want you guys to tell me what I should be doing. So basically I wrote it up as 2 hums that the chair can run, or I can run, take your pick.
Well, chairs will have to click the buttons.
True.
Okay.
So,
Go
question,
ahead.
Jim. When you say change, does that mean you would change the interpretation of existing structures? Or does it mean you would put in something new and deprecate the old?
It would mean that I would change the current algorithm and any counter signatures that have been computed for the max star or the sign 0 structure would be invalid.
So again, when you say change, do you mean actually change, or do you mean deprecate and put in something new?
I mean change.
Oh,
I intend to change the current thing, not to define something new.
okay. So maybe we should discuss that option as well.
That would make sense.
So the reason I'm asking is that we have a hard time knowing what people are using COSE for outside already. So I think just adding another counter signature, which the working title of which would be counter signature done right, and leaving the old in there with deprecation notice would be a fully backward compatible way of handling this.
True. Yes.
So what's the cost of doing that?
The cost on that is we define 2 new counter signature attributes, and we document the current one as saying it produces a parallel signature for sign 0. it potentially gives, oh, and then we mark the current ones as being deprecated. We don't want to use these. New tags in the table would have to be defined for both of those. But they're just but they're unprotected attributes in both cases, so that's a simple change in the registration.
Sounds good.
You do end up with a little bit of potential confusion with people who are using countersignatures today. I'm not exactly too sure what we do with, for example, the OSCORE document in core, because it would be using the deprecated countersignature algorithm.
Yeah, so do we have the power to retroactively fix all the other specifications that are using COSE by changing the structure, or should we do the new tag?
Well, the problem with OSCORE is it's not even using the tag. So it's got to actually specify which one it's using. Now, it turns out it doesn't make any difference because it's going to, on the encrypted structures, the new and the old, they're going to actually be exactly the same. But I don't know if there's somebody else running around who is going to be in the same situation.
Okay, I think I'm still on the side of adding something and deprecating the old.
Okay, so let's go ahead and make it 3 hums then. Does that make sense to the chairs?
Yeah.
Did the chairs go to sleep?
No, we were conversing in the background.
Okay.
It's not as obvious in this format. I will grant you that. This chair thinks that makes sense. I had one question going into this myself. This is Matthew Miller, by the way. So to reiterate, this problem is really with the sign 0 because of the lack of all the context, or correct?
Yes, although it does also affect the max.
Okay, correct. Okay. I think it makes sense for us to have 3 hums, which, to reiterate, is leave things alone. And by leave things alone, we really mean document that using this for max and for sign 0 doesn't have the intent you think it does. Work on a this fix or deprecate the current one and like either make the full change, which could break existing implementations, or have this parallel one that would ultimately deprecate the existing. Is that all correct?
That sounds correct.
Okay. So let us start then.
Well, why don't you deal with people in the queue?
Yes, I was just.
Yes, Robin, please go ahead.
Yeah, thanks. Is the microphone working?
Yes.
Yes.
Yes, it is.
Great, thank you. Yeah, I may be talking at cross purposes here, looking back at a couple of Ben's comments, but some of this some of the difficulty that Jim was describing seemed to me to be that you might try to countersign stuff that had not previously been signed, and that therefore signing that unsigned data might result in in leaving data that could be changed subsequently, resulting in a subsequent invalid signature. So I guess the first thing is, have I understood that correctly, or have I set off on the wrong foot to start with?
I believe you understand that correctly.
Okay. So then Ben made a comment at one point, discarding inauthentic data before starting to parse it is a common mechanism for robust implementation. So that sounded to me like the basis for a possible approach here, which was that if you have a string of data, some of which is signed and some of which is not, and you want to apply a countersignature, is it viable to say you should discard all the data from that stream that is not signed and only countersign what you're left with?
The issue that I can see with that approach is that I believe you would need to know what structure you were dealing with before you started doing the counter signature processing. Otherwise, you would be unable to determine which pieces of data you should discard.
Yep. Okay. So seems to me then there's a general problem of deciding the scope of what it is that you must countersign, so as not to leave yourself with the problem you described, where someone subsequently modifies data that was not cryptographically protected, and the countersignature becomes invalid as a consequence.
Yes.
Okay, thank you.
Are we ready for hums now?
I think we are. Okay, so I'm going to make sure that everybody, so there, just to point out, there is note that there in the interface, there is an extra tab on that left side for the hum. So once we click start, you will have 35 seconds to enter your choice of either low hum or soft hum or loud hum. If you don't want to hum, don't click anything and you'll be fine.
The hums are in the CodeMD, right? Because the hums on the slide are no longer the right ones.
Correct.
Thank you.
Yes. In fact, I don't have it open. I apologize. Yeah.
Okay, so if you want, I can read it. First is leave things alone, and you cannot
Here we go.
that. Okay.
So this is what we have so far. Yes, we'll probably need to read it because my screen is.
Just Control plus a couple of times.
Here we go. Is that better for everybody?
Whatever.
Okay. So the first time you'll have is leave things alone, and which means you cannot countersign sign 0. It also might have effect on max. Hum 2 will be to fix it so that countersign 0 works. The COSE sign 0 works correctly. Which could break existing implementations. Or hum 3, which is fix this by defining a new algorithm and deprecating an old one. I think there's going to be details if the choice comes. There's going to be some extra details we'll have to work through with the results of hum 3 and hum 2. But let's start with these first three. So we'll start again. Hum in a couple of seconds. If you think that we should leave things alone and document that counter signatures don't apply correctly to sign 0. Okay, hum now. Okay, this came in pianissimo, so not the quietest, not complete silence. Okay, so the next one is fix countersignatures so that sign 0 works correctly, which could involve breaking changes. So if you like this option, hum now. $15 seconds left. Okay, this one was also pianissimo. This will get interesting. Okay, so the third hum, fix countersignatures by defining a new algorithm that takes into account sign 0 and deprecating the old algorithm. If this is your choice, hum now. $15 seconds. All right, this option was forte. So at least the census in the room is fairly strong to deprecate the old and replace with a new. Now, I think some questions have to arise from this is, how do we want to go about doing this? Is this do we do all this work within 8152 BIS, or is this its own document?
Okay, so Michael, I will let you speak now.
Anything other than doing it in this document, Michael Richardson here. I think a different document won't be helpful because at the most we could say, what, deprecate the old thing? And then we would leave them without a new thing until the new document. So I don't think that's useful. I think we have to clearly and loudly announce we're doing this. Maybe we need an IETF last call to make everyone aware. But I think, I mean, at least ACE knows at this point. So that's good.
Well, I think regardless, this document needs to come back to the working group. And arguably probably also ALS. Actually, I'm almost assuming Alex will have to come back also because it will require changes.
Alex will require any changes. I will have to verify that, but I do not believe that is true.
Okay.
So I came to the mic just to point out that I don't know the answer offhand, but we'll need to check the details of whether we can go for internet standard while still defining the new thing.
That is a very good point. I was wondering the same thing myself. My
And
argument would be. Go ahead.
I see Barry is in the room, so he may have some thoughts on this as well.
My sense would
Sorry,
be that if you're making a breaking change, you have to stay at proposed standard for a while to until you think it's mature enough that that piece can go to internet standard.
Yeah, so it's good that we are not making a breaking change here. And I would classify this change as fixing a bug. And that's definitely something you do on the way from a proposed standard to an internet standard. So the reason why I think this is a good thing to do is that it sends a signal in the document that there is something different that people should be using. But if we put this into a different document, people will just read the base specification and will simply not notice that the other thing is there.
Hi, this is Russ. I think that if we put this new feature in the document, which I do believe it belongs in the base document, not a separate document for the reasons Karsten just said, but it means that we don't have the implementation experience with the new thing, so it should cycle it at proposed.
I don't think leaving it at proposed for another few months is an issue. It's easy enough to reprogress these later.
Michael, what I think you're saying is that we wouldn't necessarily need a new document because the ISD could act in a few months or 12 months or something based on the implementation experience. Is that what you're saying?
Correct. We now have a thing called a status change document, and we can just move whatever these become. Let's say it's 89.99. We can just say 89.99 is now internet standard after doing a last call on it.
I'm going to ask the RFC editor to end it in 52.
Okay. So we can confirm this on the list, but I think at this point it's pretty clear we need to find something new, and it's going to be in this document. And this document then will probably change to proposed standard. Do we have any beginning sense of where we want to go with this yet, or is that like details in this, or do we need to set up an interim discussion?
Well, why don't we take the last hum and see what it comes out as?
Okay. So the chairs will take the notes from these hums, take that to the list, point out the strong the consensus of the meeting being to deprecate the old and replace with a new, and then we'll start soliciting what that looks like. All right.
So we do have to do the last hum if you want to decide whether 2 elements or all elements. I would actually add to this, there might be a third way. And we might find out after the meeting that there is a third way, but it would still be useful to hear the sense of the room with respect to the 2 alternatives we have now.
Okay. Jim, do you have any comment?
No.
Okay. So assuming, since we are looking at changing things, or in a hopefully non-breaking way, let's have another set of hums. So the first hum will be, are we going to be aggressive with the new counter-signature proposal, which is sign everything that looks like a beaster? If you think that we should, so, and then the second hum will be more constrained on what we put through the signature. For instance, only the first and last beaster element, although this could change as we work through the process. So I guess, yeah. So hum, if we should be aggressive on what is signed for this new counter signature. Do that now.
This interface is so stupid. If you want to hum loudly, at the moment when you click on it, it's showing the number of seconds remaining. So you click on softly, and then you have to go to the other side and say, no, I changed it. Go back, click on loudly. Just entertaining you while we are waiting for the hum to complete.
Thank you, Karsten. Okay. The result of that hum was piano, which is the middle. So this will be very interesting. So second hum if we should be more constrained on what is signed for the counter signature. Hum now. All right, that was pianissimo. So rough consensus in the room to be aggressive, but I would say, if anything, half-hearted. Okay. Thank you, everybody. I think we've got some. We'll bring these to the list. We are running way over, but this discussion really did have to happen. Next up is Joel. Talk about the cert compression.
So, am I on air? Yes.
Yes.
Hi all, Joel Höglund speaking. We wanted to take this opportunity to quickly present and get some more input on a draft, which has been around for a while, but now is updated. So, next slide, please. Yeah, exactly. So this version is a merger of 3 previous drafts, and now it's 01 Matson COSE. Next. Sorry, next slide, please. So a very quick background to bring everyone up to speed before we get into the interesting discussion parts. Just stating our background and our starting points, basically. And this is to actually care about single bytes when it comes to transfer of certificates back and forth between constrained IoT devices. And as a starting point, we have been looking at RFC 79.225, which already specifies an IoT profile for certificates for IoT deployments. And on top of this, we add CBOR encoding. And by this, we can chop down certificate sizes to half in many cases. And we talk both about reconstructable certificates and where we sign the native smaller struct. Next, please. And as I said, this is where it actually matters to save bytes. This means that we do not target all available certificates. In fact, we start by 7925, and then we do even some more further restrictions. That is not to say that we should disallow everything else, but the main focus has so far been the compactness. But there is, of course, open for discussion for some of these trade-offs, and that's where many discussions have already happened. Next, please. Yeah, exactly. As mentioned, the 7925 is the starting point, and this mandates that all involved keys are elliptic curve type, including the CA certificates. And this is because the IoT devices are not thought to be able to handle more heavyweight compression algorithms. And there is also restrictions on the subject type and which certificate extensions that can be used. On top of this, we have done some further profiling to chop down and be able to implicit deduce some of these certificate fields. And we will get more into them into the discussion. Next, please. So, as I mentioned, it's been around, and now we have merged these documents which talk about the format itself and how to add IANA registry entries to use this in both a COSE and a TLS context. And of course, clarifications and simplifications on some of the details of the encoding that were not yet 100% specified, and some of them are still open. Next, please. And understandably, the overall discussion themes is on the kind of the core target. How eager to save bytes should one be? Basically, how many certificates do we exclude by our assumption versus how much complexity in the encoding do we want to add to accommodate more of the cases? And we're very happy for the discussion that has been happening on the mailing list, with many constructive suggestions and pointing out open issues from a number of participants. We're very happy for this. Next, please. Okay, diving straight into the ongoing discussions. In our current draft, the issuer field of the certificate, we have made the assumption that it can be encoded as a simple CBOR map. And that is, of course, not true for all possible issuers. For instance, it cannot currently handle the repeated attribute types. And currently, we cannot distinguish whether the original type was printable string or UTF-8. And so some of these discussions have been about what are the, can we shortcut and make assumptions versus do we need to encode all of this information, and to what degree of complexity? So basically, at some point here, I want you to start arguing for your points of view and or fill in where you think there are more needed details. But I'll keep going for the ongoing discussions. Next, please. So another issue is how much to spend, how much bytes to spend for encoding algorithm types and parameters, where we currently have one integer for signature algorithm and one for public key info. And this, we believe, is sufficiently future-proof for our target algorithms to enumerate those that we think are relevant. And then mapping back to the 7925 starting point, we have only considered algorithms suited for IoT targets, meaning we have not considered RSA type of cryptos, even though this has sparked some discussion on the mailing list. For sure, there are RSA crypto certificates out there, but our starting point has been that they are not relevant for the type of IoT scenarios that we mainly target, meaning that we don't think they are necessarily in this context. But of course, this can be questioned, but we have not seen this as we have not seen it's worth to include in IoT deployments. Next, please. And then, of course, the current draft has a very simplified encoding of extensions, where we don't encode the order, and we're also where the extended key usage is a bit underspecified. So here we have had many helpful suggestions on either which ordering can be assumed or how to uniquely encode a specific extended key usage order. We believe this discussion needs to continue also on the mailing list. Next, please.
Joel, I just want to point out we are technically over time here, and we're about to get all kicked out here shortly.
Oh my. So thanks for the warning. And then there is an ongoing discussion on extensions, further extensions, whether CA certificates could be included or not, and how to handle that. And finally, next, please. Whether this is more terminology, whether it should be called certificate compression or only stay as a TLS certificate type. And all of these issues, we had some input, which we are investigating, but we are very happy to have an ongoing discussion on the mailing list.
All right, I think your last two slides. All right, so any quick clarifying questions? We have less than 2 minutes. All right, thank you very much, Joel. We'll take further comments on the list. Sorry, Jim, that we could not get to the next one, but I think you may have a lot of work ahead of you anyways. All right, unless there's anything super pressing, I think that concludes our meeting for today. Thank you, everyone. Thank you again, Francesca, for taking minutes. That's tremendously helpful. And we'll see everybody on the list.
Yes. Thanks, Francesca.
One last thing, if you have more ALGs, tell Jim or the list, preferably the list. Thank you all.
Cheers.